Okay, good morning, everyone. Welcome to the session 2 for GNA for managers. What we'll do is um, we will today, the agenda is to, of course, we'll do a quick recap of the concepts that we learned in the first session. And then we will dive deeper into how to leverage this large language models, the generative AI models. We will dive deeper into a concept called prompt engineering, which is an important capability of generative AI models. And we'll look into a couple of key providers like OpenAI and Anthropic. What is the full capability they provide? And we'll also go through a couple of case studies, the real world case studies, how people have applied this solutions and what problem they were solving and what were the challenges. Right? And in the meantime, also we'll do a couple of hands-on. I will see how much time we have for the hands-on. Otherwise, we'll do it a little later. So let's start with a quick recap. So in the first session, we we went through about 4 or 5 key concepts. One was how generative AI is different, right, than your traditional AI. We went through an example of classifying the sentiments of reviews the customers provide, and we saw that how complex it is and how the traditional way we have to build multiple models to accomplish the task, but in generative AI you can simply use prompt engineering. But we'll dive deeper into that today. We'll look into what are different best practices, the patterns around prompt engineering, and what are the other key use cases or capabilities that we can actually, develop around that. Second one is how generative AI is a multitask learner. Because in traditional AI, typically the approach is to develop a model for every task that you accomplish. There are like single task learners. But generative AI, which is based on the foundation of a language understanding, is capable of doing multiple different tasks at the same time. And the third one is we also looked at some of the foundational blocks of generative AI, which are essential for us to understand, especially if you're working on generative AI and building solutions. For example, embeddings. We also looked at tokens. We also looked at attention. Anything else? Yeah, these are the, and one of those most important concepts is embeddings. Right? How your word and sentences are converted into numerical representation that semantically represents those sentences and words. And we looked at one example of search based on the embeddings. And then finally looked at how these models are built, what we call a foundation model. A foundation model is something that is capable of doing multiple different tasks. And how these foundation models, for example, your OpenAI GPT-4 or your Anthropic Claude models or your Llama model, which are open weight models, how these models are actually built. And we saw that they're actually built in multiple stages. And the first stage is called pre-trained stage, in which we provide a large corpus of data. And we saw that the corpus is a mix of all possible data, your internet data, your GitHub code data, your stock exchange data, your news, right? It's a mix of all possible data. And sometimes it's also a combination of multiple different languages, multilingual data. Of course, the representation of English would be very high compared to other languages. That's why we typically see these models actually perform very well when the interaction is in English, but also over a period of time, they are actually collecting more multilingual data, more representation across different languages, and then training. So pre-trained model, which is primarily based on next word prediction. And then there's something called fine-tune or instruction tune model. We also call it SFT, supervised fine-tune stage, where these models are kind of trained to respond to questions. And with an analogy that we actually learned in the first session, that we are reading a chapter. Let's say we are reading a particular chapter in a subject. So you are actually learning all the concepts, the terms, the terminology and everything. But at the end, there is an exercise which also helps us to respond to specific questions about the knowledge that you have learned in the chapter. So pre-training is more like reading the chapter for the model. It's making sense of all concepts, words, everything. But fine-tuning is more of a question answers, which ultimately we experience. If you go to ChatGPT, you ask a question and responds with an answer. So it's also trained in that particular fashion of what we call it a prompt response pair. So the first thing is these models are trained based on the corpus to predict the next word prediction, which actually helps you to understand the corpus, the words, their structure, their semantics, everything. But then it's still not capable of responding it to a question that we're asking. For example, we ask a question, can you summarize this? Can you extract certain information from this paragraph? Right? Can you answer this question in a particular format? Right? Can you respond to the question and provide the response in a structured format, right? All the different ways how to respond, the style of response, that is something that we learned in the supervised fine-tune. There's also a third stage, which I'll come in the next session, next last session, we call it alignment session. Sorry, alignment stage, which of course we will look at later, right? So these are the things that we went through in detail in the first session. And given that we have gone through this, now what we'll do is, if we have access to a foundation model, how we can actually leverage this, or how organizations are leveraging that model to develop or build solutions. That's something that we're going to look at in this session. Just to quickly confirm, is my audio correct? I might be having some internet.
It's all clear here.
Yeah, thank you. So one of the most important capabilities is called prompting. But before we do prompting, let's look at one case study first. We'll start with the case study and end with the case study. So this is a case study from a company called incident.io. I'll send you the case study after the discussion also by end of the session. This case study is how this company, which is primarily building tools for organizations to kind of collaborate and help solve them incidents. Okay, this could be software related or it could be any other incidents. So incident IO is an incident management tool which helps organizations collaborate with when responding to incidents. One of the big challenges is when multiple people are working on a particular incident, the information is scattered, especially when they're using a collaboration tool. Let's say you might be familiar with something like Slack channel, right? Or a Discord servers, where people keep, wait, somebody joined. So when people collectively working on an incident, they normally, whatever information they find, they put as in the form of message. Now, let's say the another person who is working on the incident or a new person need to go through the history of all the messages to make sense of what is this incident about, what information we have, or what is the knowledge that we have so far about the incident, and what we have done so far about the incident, and what is there to be done, what's remaining, right? So the person who is actually working on this particular incident has to make sense of all this information by going through all these messages historically that people have put into Slack channel, right? So one of the key part of that is incident is something called summary. So rather than going through all the messages, can you summarize those information in the channel? So when ChatGPT was launched, so they found, is there a way that the AI can make it smarter product experience for their customers, right? So one of the developers wrote a prototype to summarize an incident using all updates, like a Slack conversation and other metadata, right? The incident reporting system or whatever. So it can go through all possible systems and collect all the information and summarize it. So what they did is they try to, after the prototype, they see the possibility of solving the problem, and they actually built a working version in 5 days. That's an important point, because like we last time also we discussed that how generative AI is actually help us build solutions much faster, because we mostly don't train a new model. The training part of the model is kind of can be skipped when you're building solutions in generative AI. In traditional AI, you have to actually collect data, train a model, evaluate a model, right? Here still you have to evaluate it, but probably will not have to evaluate a model. So they came up with this concept called suggested summaries, okay, by the system itself. Whenever you provide an update about the incident, okay, so what's happening, that gets broadcasted to the incident Slack channel. We all use OpenAI's models to suggest a new summary of the incident. So somebody updates a message, it goes to the all previous conversation along with the new conversation and creates a summary of the incident, very quick summary. For example, like this, somebody had updated a message. Now quickly it proposes a summary, right? So it has 4 important attributes. One is what is the problem, what's the impact, what are the causes, and what steps to resolve. So in summarization, these are the key facts derived from the previous conversations and creates a summary, and asks the user to accept or edit the summary, or basically also has a a feature saying that the summary is not good, it's a bad suggestion. So this suggestion will consider your update, conversation in the channel, and the previous summary if there was one. Okay, and of course it gives the benefit to the people to have an update, up-to-date incident summary. And when they released this particular feature in the product, the reaction was better. We could have hoped for. They were looking for it. And what happened is of course, before that also they had this feature which was created by the humans, right? So human summary update and AI summary update. And when they realized that, once they release this particular feature, people have started using the AI summary more than the human summary updates. Okay, so AI summary, of course, it was much faster. The summary was created. So the usage of that has increased more than the human summary. Now, when we first started scoping this project, there was some debate over whether we should either propose a new summary and ask human to accept or reject it, or automatically update the summary, but give a human the option to undo this. Okay. So they realized that, sometimes the summary that is suggested by the AI itself is not that factually correct. Okay. So they're realizing that whether they should in fact do it, or they would actually use a human in the loop. There's a concept called human in the loop to summarize to actually verify the summary and then suggest it. But they realize a fresh summary with potential inaccuracies would be better than a stale one. Because if you use a human in the loop, the time to create the summary basically is the lead time is very high. Okay. So it so might happen that when the human creates a summary or verifies it and provides it, it will be too late. In the meantime, there will be much more updates by the collaborators. So this is a very interesting case study. Of course, I'll send you. And of course, because they're factually inaccurate, they also thought about providing a feedback button, which is very important when you build AI solutions. There must always be a feedback button, right? There always, like if you go to ChatGPT also, whenever it responds to a question, there's always a option of thumbs up or thumbs down. Or if you've also noticed that sometimes it generates two different responses, if you've seen that, and ask which one is better, right? So it's a continuous human feedback that actually, uh, creates, it helps you to improvise that particular solution by getting the feedbacks from the users. And when we suggested summaries, over a period of time, they checked how the summary was being accepted by the customers. So 63% of the time it is accepted as it is. 26% of the time it is edited. So they add some additional information to the summary that's suggested by the AI, and 11% of the time it is rejected. Okay. So that is okay. And the reason is, one of the key reason is prompt engineering is hard, because the way they were creating summaries is purely through prompt engineering, right? Writing prompt to kind of analyze the previous conversations and create the summary. And then they realized that the prompt engineering is not very deterministic. I'll talk about why it is not deterministic and how do I actually make it more deterministic, right? And then they realized that prompt engineering is both a science and art, right? Again, we'll look at why this is science and art both, little more detail. Okay, so I'm going to send you this particular case study. Please go through that, and we'll come back to it once we've gone through some of the concepts. Now let's look at why prompt engineering is so hard. So now let's look at what is prompt engineering, or what is prompting itself. There's a difference between prompting and prompt engineering. So prompting is basically the act of providing a question or statement to elicit a desired response, right? This is both science and art. That's basically we saw in the case study itself. In the meantime, if there's any question, are there any questions? So when we write prompt, typically the prompt has a definite structure. And the structure comes from how this foundation models like GPT-4 or Claude or Llama are actually trained. So when they're trained on this prompt response pair, how these questions are actually structured in the training data, the model is basically kind of tuned to that. So over a period of time, people have realized that if you follow a certain structure in writing the prompt, typically the response is much more desirable, right? More what you expect the response, it provides that kind of response. So if you look at a prompt, typically the prompt has specific elements in that. For example, typically a prompt contains something like a role where you define what is the role and the response should be tuned to that particular role. There's also an instruction. We look for example and then probably much better. There'll be some examples of the task that is asked to accomplish. So this is of course an optional component. Not necessary you have to provide examples. Sometimes these foundation models are trained so well on certain tasks without providing examples, it can actually accomplish that task. Some additional information or the context, and then the question that you provide. For example, if you look at the case study that we discussed last time about classifying a particular review about a restaurant, right? This is the kind of prompt that we provided. So if you look at this, you are skilled sentiment analysis AI specialized in extracting detailed insight from the text review. So this is kind of a role, right? You are an analyst, which can actually, review the the customer reviews, classify the reviews, and provide the desired response. So this is basically a role that you're playing, and this is the instruction what exactly you have to do. For example, analyze the provided restaurant review to extract sentiments about food quality, hygiene, and customer support. And this instruction is very clear, right? And identify relevant keywords and provide the sentiment as either positive, negative, or neutral, right? The instruction is very clear. So this is kind of a role. This is an instruction. This is the context to that. What exactly you're probably, why you're asking for this particular review to be classified in a certain manner. And this is also part of the instruction where we are saying that the response should be given in a JSON format, right? And this is basically the question that you're asking. So given that this is the instruction, the context, now can you provide or classify or extract information about this specific review, right? So not necessarily you have to have all the elements every time you ask a prompt to the model, but typically if you ask and keep the structure fairly similar to this, typically the response will be much better. So there is a nice report published by quite a few organizations, if you see here. For example, OpenAI, Stanford, Microsoft, Princeton, everybody came together and created a report. Let me show the report to you. So what are different prompt techniques are possible, available, right? So this is actually a prompt report, a systematic review of prompting techniques. What are different possible prompting techniques are there? And in that, they have actually also given what are the different components of a prompt. If you see, there are variety of common components included in the prompt. One is called directive, it's very similar to the instruction. Examples, if you provide examples of what task the prompt is asked to accomplish, okay, so that can be provided, of course, an optional component. Output formatting, right? You should also provide what is the desired structure of the response. Okay, for example, you want in a CSV format or JSON format or any specific format. We'll come a little more discuss about this in a little later about how to actually control the schema of the response itself. Okay, you can actually provide a schema explicitly to control the response from the models, right? Style instructions, role, and additional information, nothing but a context. The terms are a little different, but the concept is same: instruction, example, output, formatting, role, and context. And then came up with this beautiful, list of an hierarchical set of prompting techniques. And if you look at that, this is primarily for text-based prompts. There are 1, 2, 3, 4, 5, 6. 6 major prompt techniques are there. And within each, there are, of course, some subclasses of techniques out there. Of course, this comes from the research. Of course, you won't be using all of them, but at least you should be aware of what are the high-level prompting techniques are there. Okay. So what we'll do is we'll go through examples of each one of them. So what is zero shot? What is few shot? What is chain of thought, ensembling, and all this? And then look at how these prompts are being created. So if you look at, there are typically 6 core, at a high level, 6 core prompting techniques are there. So zero shot prompting, few shot prompting, chain of thought, chain of verification, least to most, and cell consistency, right? So at a high level, these are the most widely used prompting techniques that I have taken out of a lot of papers and case studies that people typically use. Of course, there will be some more would be there, but you should be familiar with all these 6 techniques, at least conceptually. So now let's look at the prompting techniques one by one. I have actually developed a separate notebook for this, which of course I'm going to send you after the session. Once you go through all these techniques are there. Okay, so let's first look at a zero shot prompting. Zero shot prompting is our default prompting, right? Which of course will follow some structure to this, but this is without any examples. It's called zero shot, right? The zero stands for no examples. Okay. In this case, we are assuming that the model is capable of accomplishing the task, responding to the prompt, because the model has been trained very well on this particular tasks, right? So that's called zero shot prompting. And this is also something that we use as a baseline. So whenever we build a solution, we typically use zero shot prompting to baseline the response. And then we do prompt engineering. Okay. The prompt engineering is nothing but, once you write a prompt, you make modifications to the prompt in iterative fashion until you arrive at a prompt that gives you a desired response, right? So that's basically called your prompt engineering, right? You are actually, improving the capability of the prompt so that it actually achieves your final goal. And you start with somewhere, that's called your baseline prompt. And typically zero shot prompting is kind of used as a baseline prompt. So this is again the same example that I have shown you before. So here we have a role, instruction, the context, and this is a desired response that we want, and this is a review, right? So here, see if there are no examples, and this is called zero shot. The few shot is exactly same kind of prompt, but it has an additional section called example, right? So whatever task you want to accomplish, you normally provide a review and asking for a response. The same thing that you give an example. So given this is the review, this is the response. So now if you can learn from it, okay, so can you respond to the questions now? So this is also known as something called in-context learning. In-context learning. So in-context learning is if your model is typically not trained so well, the foundation model on a particular task, but it has a capability to learn on the fly. So if you can simply give examples, it quickly learn from it. And in a few shot, okay, this is also called one shot because you're given one example. In a few shot, you can give one to many examples. Okay, you typically can give one, two, or many examples. Most of the times we give multiple examples so that it actually learns better, right? Because if you give an example of one kind, that's everything is positive, nothing is negative, the model may not learn very well. So you have to kind of give examples which are representational, some positive, some negative, some mix of positive, negative, and so on and so forth, right? You can give multiple different examples. And this few shot prompting is, these examples again need not be fixed. These examples need not be a fixed set of examples. Fixed set of examples. So they can vary based on what is the current task that you have had. For example, if you're asking to review a particular, classify a particular review, now you can pick up examples which are very closer to that. So this is, though this looks like a very simple solution, but this is actually a complex solution. So let's look at some important aspect to that. For example, the same paper only they have provided, when you do a few shot prompting, there are many things matter, right? One is the quantity of examples that you give. You're giving one example or giving multiple different examples. Typically, giving multiple examples give better results. So always give more examples. The number of examples, of course, depends on the kind and complexity of the task, and which of course can be benchmarked for your specific use case, but it can give multiple examples. The example ordering is also matters. It's a very subtle, but it also makes a lot of sense. For example, if you in the examples in the prompt that you give, if all the positives are the first few examples and then all negative examples, typically the model has a tendency to learn from the latest examples. This is what people have done benchmarking. So when you give examples, make it random. Some positive, negative, mix them. Okay. So randomly order these examples. This is also very important. Then level distribution. So let's say you have a more number of negative and only one positive. Then also this could be a problem. So ensure that the distribution of examples are fair. For example, 50% are positive and 50% are negative, depending on number of classes you have. Okay. So again, you have to kind of representational of examples from all classes, right? The level quality, okay, ensure that these are correct examples. So these examples are typically, created or annotated by humans. Okay, ensure that it has gone through the review process, because if the examples themselves are not good, the model and output itself may not be so good. Okay. Example format, ensure that you always choose a common format, especially if you use a structured format like a JSON and all that. It ensures that, so every example output should not be very different. Then again, the model may not learn properly. Okay. And then there is something called exemplar similarity. Okay. So this is actually a little bit a harder implementation to do, but I'll actually tell you how to do this. So what normally we do is, let's say in the restaurant review example, all right, you can take, let's say, about 100 reviews and annotate them by humans or experts. Right? You can actually have humans who go through the review and create the response output, and you review them, ensure that that's a gold standard. Okay, this is a gold standard, and then you store that into a database or some storage. Now there's a new review that is coming, right? And you want to send a prompt to the model. The new review has come, and you want to send this review to the model LLM to classify it. Okay. And while sending it, you want to take some example, right? Some classified reviews and example along with the review so that LLM can do a better job. Now we have 100 examples here. Now, which ones you take? So what you can do is, this is where you can find something like, are there any reviews in my example repository which are very similar to this? Right? I can pick up only those examples here. But how do you know their similarity? This is where again comes embeddings. Remember, we learned embeddings last time. So what you do is, you take this review, you generate a numerical representation of the review, and then the database, all these reviews have their own numerical representation. And then you can do something like cosine similarity. And find out which ones have the very similar semantics, right? And then you pick up them and add to the prompt in the example section, and then send to the LLM. You can see that how complex this implementation is. So whenever you get a review, your role, your instruction, your context, everything remains same, but the example section of the prompt keeps varying, okay, based on what is the current review that you're asking the model to classify, okay, and based on that, you can pick up the right examples from the database and do it. So this is where typically your vector store, you must have heard about vector store or vector DB, which comes very handy, right? You can store all this in the vector store database. When there's a review comes in, you pick up that and basically send to the LLMs. So few shot prompting is quite widely used in the industry, and because these models are capable of doing new tasks, given that you give them the right examples so that they can learn and do a newer task. But how these examples has to be embedded into the prompt, you might have to follow some of these guidelines given here, okay? And this will ensure that you get a better result. Okay, I'll just stop it for a minute and ask if there are any questions. Okay. So now let's look at the next one, which is called chain of thought prompting. So you looked at zero shot and few shot. Now let's look at chain of thought prompting. In chain of thought prompting, if you have a very complex task to be accomplished, typically we used especially when you have very complex tasks. Right? This is very similar to the concept that we have always learned, right? When you have a complex system, you always decompose that into simpler subsystems. So what you do is, this complex task, you decompose that into smaller subtasks. So you ask the prompt to decompose the task into smaller tasks. For example, here if you see, and say you are an expert financial analyst and designed to interpret company performance reports, provided detailed step-by-step insights. So of course you can ask this and provide the report. It will give you some insights. But then if you also tell how to decompose this analysis into smaller subtasks, for example, you can tell him that when you're analyzing the report, you decompose that into subtasks like look at the revenue trends in the report, right? Identify whether revenue is growing, declining, or stable, okay? And explain the drivers behind the trend. Look at the profitability metrics. Look at operational efficiency. Look at market positioning, forward-looking statements. So you are actually specifically asking how to decompose the task. And once you looked up everything, then you summarize the key findings and provide overall conclusion, the company's performance, right? And if you can provide this kind of chain of thought, right, when you are accomplishing a task, so rather than jumping into summarizing the report, it first decomposes and extracts specific information from the report as specified here, and then summarize, which typically gives a better result, right? And of course, can also provide an output format. And here is something like an example also is given here. So you can mix chain of thought along with few sort, right? So this can be also mixed. Sometimes you use chain of thought independently, and sometimes chain of thought along with a few sort, where you can give examples of that. It learns much better, right? And it gives you much better analysis of that. So here is the company report. Of course, I've taken a very small example. Typically, the reports won't be so small, but you can, of course, because nowadays the models have a very long context window, you can give a very large report, and then you can also it'll extract the right information from that. So this is chain of thought prompting, decomposing complex tasks into smaller tasks so that you can actually do a step-by-step analysis, step-by-step response, and summarize later. Then there is something called chain of verification. This is very important, especially because the models typically tend to hallucinate and provide a non-factual findings from the report sometimes. So what you have to do is you ensure that you provide a mechanism to also verify the response that has gotten from the model. Okay, so chain of verification is a structured prompting technique, okay, which does reasoning and verification. This can be done into either one step or a two-step approach. Typically, two-step approach is always advisable, again, widely used. So what you do is, in the two-step sequential prompting, it's a sequential prompting, right? So you first do the first step and do the second step. In the first step, you generate an initial response. In the second step, you verify and critique. Okay, so self is called self-critiquing, right? The response from the prompt, and you provide the final response. For example, in a COV prompt generation analysis report, right? In the first one, what it does it, you give the financial system and design to analyze the company's performance. You ask the model to go through each one of them and summarize it, right? And second one, you generate a verification report. So basically saying that it's, for example, if it says the revenue trends, it says positive with 15% year-over-year increase driven by core market sales. Now, what you need to do is you go through each one of this final summary results, and then you ask them to cross-verify whether this particular factuality that is derived from the report is actually available in the original report or not, right? So saying revenue trends, where we check if the reported revenue trends align with the context or not. First you give the context, right? You summarize, and then you do a verification saying that whatever is summarized is actually available in the context or not, to ensure that the model has not hallucinated. So this is a wonderful mechanism to kind of reduce the error in the report. So you provide a prompt saying that check if the report trend aligns with the context, verify if the profitability analysis matches the data on margin or cost, right? You can actually have a set of verification strategy and ask them to do it. So it generates both the analysis report and the final example saying that status is correct or incorrect. If it's incorrect, you can also ask an alternative response from the model. Okay. This is very highly used, especially when you're prompting to derive key findings in a report, especially when you're summarizing, right? And to ensure that, the model does not hallucinate and does not provide non-factual findings from the report. So this is called chain of verification. This can also be done, by the way, in a one-step approach itself. You can provide both the steps to generate the insights and the verification. Both you can provide. Typically, models are nowadays more capable, especially if you look at your GPT-4o, O1 models, which are more reasoning models, they can do multiple different tasks at the same time. First, it generates, then it verifies, and then if required to make a correction, and then basically gives the final response to that. Okay, we'll come to something called in the next session. We'll come to something called agents, right, which are an extremely important solution framework around generative AI, which can do this task much better, right? But you can follow this pattern using agents much better, right? You can do chain of verification also. Then there is something called list to most prompting. Okay, so we have looked at three different now. One is zero shot prompting, no examples. Few shot prompting, where you can give examples, but how these examples are included in the prompt, we can actually follow certain rules or best practices, right? Like a level distribution, quantity of examples, the ordering of examples, the similarity of examples, right? All these things can be taken into account. Then there is chain of thought, where you're decomposing a larger or complex task into smaller tasks and then do step by step. Then there's something called chain of verification, right? You generate a response from a context, and then you again verify if the response aligns with the context, all right? If the information is available in the context, then you can use chain of verification. Then there are two more. One is called least to most prompting technique and self-consistency technique. So let's look at two different examples here. Least to most prompting technique is again kind of response we need, especially if you use for like customer support kind of scenario. Or if you look at this particular example, it's saying that You are an HR system tasked with evaluating candidate applications. Your objective is to verify whether a candidate fulfills all the must-have requirements for the specific job, one rule at a time, and follow the steps using the placeholders provided. So here what happens is, let's say, in this case, the applicant's profile you have, right, which is given in the context of the prompt. And then you have a job requirement, right? And job requirement have set of rules. Rule number 1, rule number 2, and so on and so forth. And then what you need to do is, you need to verify these rules against this context applicant profile, one at a time in a particular sequence. Okay. So these rules has to be applied in a particular sequence. So if the rule, first rule satisfies, only then move to the rule 2, and then move to rule 3, and so on and so forth, right? This is very similar to chain of thought, but the difference between chain of thought, where you're still decomposing a complex task to a subtask, here, if you look at all these subtasks, they can still be done independently. They are not dependent on each other, right? So revenue trends, profitability metrics, and all that, they can be extracted from the report independent of each other and then summarize it. But here, least to most is, for example, say verify the candidate's educational background. And you say if the rule 1 passes, then proceed to rule 2, right? If the rule 1 fails, reject the applicant and provide their feedback. So it becomes much easier to generate a response also like that. Then step 2, confirm the candidate's work experience. So this is done only when the rule 1 passes. If the rule 2 passes, then you proceed to 3, or reject the applicant, provide the right feedback, right? So this is a nice way of providing a prompt, because this would actually help us to verify if certain conditions are met for the final response or not. Especially, for example, refunds processing, customer support, right? Customer support, when people ask questions in the chatbot, you go in a certain sequence, right? Ensure that whatever the customer is asking the chatbot, it satisfies all the rules before you responding to the customer, right? So this least to most prompting is very widely used in this kind of scenarios. So you have a set of rule, step 1, step 2, rule 1, rule 2, and then you have also conditions if it can go to the next step or the response has to be generated there itself, right? So you can provide all the steps and then provide. So this is also an important strategy that we follow, least to most prompting, still decomposing, but going in a particular sequence. These are real world prompts. And if you understand these techniques, it will actually help you to build solutions in much better way. Then the final one is, let me look at the final one. The final one is called self-consistency prompting. Okay. The self-consistency prompting is a very interesting technique. It's also known as, by the way, is also called ensembling technique. Self-consistency prompting. Yeah, this is also called, by the way, ensemble technique. You must be very aware of the technique called ensemble technique from machine learning. If you've done machine learning, what we do is sometimes we use multiple models, like your bagging model. So let's say you say, is the customer going to churn, right? Or is this transaction a fraud or not a fraud? right? Typically what happens is we build multiple different models, right? So model 1, model 2, and model 3. Typically people build hundreds of models, right? For example, there's a technique called stacking technique in Ensemble, where you can use a linear regression, a decision tree, a KNN, right? Logistic regression and models. And let's say this model says it's a fraud. The probability of being fraud is very high. This also says fraud, but this is a non-fraud. Then what you do is you take a majority of the decision. Let's say out of 3 models, if 2 models says fraud, then it's likely that it's a fraud. Okay, because sometimes the fraud patterns are so complex, which cannot be understood by one single model. We typically tend to use multiple models, thereby reducing the something called variance reduction strategy that we do. Okay, where the uncertainty in prediction typically becomes much smaller. The same thing can be applied to also in prompting technique. So what we do now here is simple example of prompting. For example, let's say you have a customer query and you extract the following structured information from the query. Okay, let's say this is much more complex. What's the issue type? What's the troubleshooting steps taken, and what's the possible causes? Because possible causes could be very complex, right? So what you do is you generate multiple responses. Okay, so this is something very interesting. For the same prompt, you give one prompt, right? You give one prompt, but you generate multiple different responses, R1, R2, and R3, right? And then what you do is you look at all the responses outcome, and then finally see all these responses are typically agreeing upon what specific possible causes. You can also order them. For example, if you see here, my smartphone has been freezing frequently over past month. It happened randomly, and basically the customer has explained what is the experience, and you identified possible causes could be low RAM or outdated app, low RAM, hardware aging, or insufficient RAM and software glitches, right? You can see most of them are still agreeing on low RAM, so that could be the first possible causes, right? In this case, so you can also order those causes based on how multiple responses are agreeing upon, right? So this is very interesting. You can use multiple models. For example, you can use a GPT-4 here. You can use a Claude model, and you can use a Llama model. Of course, this is going to be very expensive. You don't do this unless the uncertainty in the response is very high, and you want to ensure that you have a multiple different perspectives. This is almost like look at my prompt, have a different perspectives, and then basically summarize that, right? That's possibility. But you can also do something like you can still use GPT-4. Okay, you can still use GPT-4 model, the same model across multiple responses, but you can configure the model to have different responses. Okay, I will come to that, how to control generation. You can actually provide the same prompt and configure the model to create multiple different responses. Okay, that also you can do that. So this is basically called your self-consistency pattern prompting technique, where you provide the prompt to the multiple different models, or you can same model with the different configurations to generate different kind of responses. People also use this especially when they do creative writing, because creative writing, if you have multiple different perspectives, and this becomes much easier, and then you can ensemble at the end. But how to control generation? The same model, given the same prompt, how does it actually create multiple different responses? How to actually do that? We'll look at that now. But before that, again, I'm going to break for a minute to see if there are any questions on there. Are there any questions?
We have one question from Yashwant, which is how do we consolidate responses?
Yeah, interesting. So again, you have a prompt to send to different models. And then what you do is all the responses, again, you send to another model, another LLM, which is a more capable LLM, like a GPT-4, right? Saying that these are my responses. Now, can you consolidate and give me the final response? That's one technique. So you are using 3 different models or 3 different interactions here, and there's a final one more interaction here. Or what else you can also do is, if this response that is generated is very structured, right? Like a JSON and your specific fields where you capture that, then you can have a programming interface where you look at the response generated and look at, okay, what is the classified, right? So for example, this is, of course, that can be used only when it is much simpler to achieve that. For example, if you are building a model to classify and so I have seen one use case where people used a customer request and there are multiple models, right, which is kind of do a severity detection. I think you must be knowing, right? Bug triaging. So severity detection. So there's basically an incident or a bug reported, and there are multiple different models because the bugs could be so complex. So one basically says the severity 1, okay, a very structured output. Just one output by saying that it's a severity 1. It says severity 1. It says severity 2. Okay. And then what you do is, because these are very structured outputs, you can have a simple programming interface to kind of do a polling, right? Saying, okay, the 2 models are told, 2 responses are told is severity 2. So the bug can be actually, the bug or the incident can be classified as severity 1. Okay. So that also you can do. So it all depends on the response type. And the response is very structured. We can have a, the deterministic way of, programming way of determining what the final outcome is. But the responses are more of like a creative writing. Okay, so there's no way to so you can send to another model, which is a more capable model. As of now, GPT-4 is probably the more capable model, or Anthropic Claude Sonnet models are more capable model. You can ask to kind of consolidate all the responses into one single response. Okay, you have to write the prompt for that. Okay, are there any other question?
Second question from Yashwant is, what is the most cost-effective model for this self-consistency technique?
Okay, we'll come to the cost later. First of all, self-consistency, you don't do it, especially when the cost is a constraint, because you still have to use multiple different models. But one way to minimize the cost, to assume that you control the cost, is kind of the intermediate responses can be generated use less capable model. For example, if you know the OpenAI model set of models, you can actually use GPT-4 mini model. Okay, minis are also quite capable models, and the cost of mini model is much lesser compared to the high-end models. So for this, you can use a GPT-4 mini model, But for the final consolidated response, you can actually use GPT-4 model, right? So that way you can actually minimize the cost. So final responses, consolidation, more capable model, but this is probably you can use GPT-4. Or probably you can also use something like your local models. We will come to some open source local models in the next session. I'll talk about which are pretty good models that you can locally deploy, and also you can get equal good responses. Any other questions? Okay. Yeah, I think that.
We've got one more question from Anubhav. So if we are going to implement any LLM, we try 2 to 3 prompt techniques and see which fits best, or are there any best practices?
So these are the best practices, right? But which of this technique will apply to your specific business problem? Yes. Out of these 6 techniques, right? Maybe typically you always try the few sort example. That's the most important, few sort, along with probably chain of thought, right? That's a typically people try always as the first step towards implementing any prompt solutions, right? If you look at most solutions, people use few short examples and chain of thought if it's a complex task. Okay. In spite of that, then you can probably add an additional verification stage or self-conscious. So these are best practices. Okay. And now, which of these techniques will help you? You have to have an evaluation strategy at the beginning. Even before doing a prompt engineering, we'll come to evaluation strategy. Next session, we'll talk about how to actually evaluate these models and what techniques are there. So you have to have an evaluation strategy. And, prompting is more of a trial here, not trial and error technique. So you should be, always ready for doing a lot of trial and errors, but you can start with a baseline, which is a 0 shot, then try a few shot with chain of thought. Most of the problems can be solved using those techniques, but additionally, you may also need other techniques depending on the kind of business problem you have. And every step you have an evaluation strategy which tells you what is that additional benefit you're getting out of adding those complexity of prompting, right? So that you can measure the benefit out of it. Yeah. Any other questions? Okay, now let's look at model parameters to control generation. So if you go to especially, let me see, I'm not sure whether you have seen this particular interface for ChatGPT or GPT. So if you go to platform.openai.com, right? And in that there is something called playground, right? Typically we go to the ChatGPT interface, which is the standard interface that we see here, right? The standard interface that we see here, where you can actually, create a new prompt and so on and so forth. But there is also another interface which is much more and provide much more control, which is actually your playground interface. Platform.openai.com/playground. So if you see here, it also provides multiple different APIs. I'll come to these APIs later. This is a default chart interface, right? And where you can select your model, which model you want to use. Okay, you can also select your response format directly here. By default, it's a text. And then you can see there are a lot of model configurations that you can actually apply. For example, one is called temperature. One is called max token. You actually controlling the number of tokens in the response, how big the response should be. Stop sequence. Then there is something called top piece sampling. We call nucleus sampling. Then frequency penalty and presence penalty. You see the quite a few parameters that you can actually configure to control the response from the model. By default, these are available as part of the API. When you write a program, this can be set. But the default ChatGPT interface does not have it. Okay, you don't normally do that. But here you can control much more better. Right? So what is temperature is temperature can be set somewhere from 0 to 2, most of these parameters. 0 means more deterministic response, right? So controls randomness, lowering results in the less random completions, okay, more deterministic and repetitive. But when temperature increases, let's say temperature becomes 2, okay, this is basically more of a much more random and typically more creative response. Okay. So if you remember the basic paradigm of model, the way these models are built, right? Let's say I love to, right, drink. This is my input to the model, right? And what the next word? It could be coffee, it could be tea, or it could be any other drink, right? So now what the model's objective is to kind of predict that next word, right? So basically say, let's say there's a word called coffee, there's a word called tea, that's a word called, let's say, beer or something else, right? Now, what the model will say, okay, the probability that the coffee is the next word is very high, 0.7, tea is 0.3, 0.2, or so on and so forth. Of course, let's say 0.5, so on and so forth. And then, of course, it takes the most important word and basically says, okay, yeah, it completes the sentence with coffee. Okay, but this is possible when the temperature is 0. The temperature is 0. One of the word, the most possible word, the probability is very high. The temperature becomes 1 or 2, then what happens is this predicted probabilities, right, becomes uniformly distributed, right? So the temperature, yeah. So when the temperature is 0, we have a very narrow distribution. For example, I ate the pizza while it's still hot. The way the predicted probabilities are computed, one of the word becomes extremely large and rest all are very small. But when you move towards higher value of temperature, the distribution of probabilities are not very high. Okay, so that means the difference between the first word and second word is not very high. Here it's very high. Okay, so the model doesn't really know. Let's say, for example, this word is probability is 0.4 and this is 0.439. Both could have been the next possible word, right? So if you increase the temperature, the distribution becomes very broad, not a narrow distribution. So it can either select the first one or the second one. Now, how does it decide which one to select? That's actually given by something called top P sampling. Top P sampling is, if you reduce that, let's say I reduce that to, let's say, 0.6. So what it does is, he looks at which are possible words, the cumulative probability. Let's say this probability is 0.2, this is 0.19, it's 0.18. The cumulative probability is about 0.6. The top P, the top probabilities. So now let's say the first 3 words or first 4 words together is 0.6. Then randomly select one of the words from the 4 words. But in this case, if we look at 0.6, only the first one itself fulfills that. So there is no possibility of choosing any other one, right? So by controlling the temperature and top P sampling, what you can do is you can actually enable the model not to just pick up the most probable one, it can also have some variations in that. That means moment you increase the temperature and top P sampling, you can see a different different possible responses from the same prompt only. If you give the prompt, for example, if you give the prompt here to the model and say, this is a temperature 0, let's say for all of them, the top P sampling is 0.8. I'm just giving an example, but here the temperature is 1 and here the temperature is 2, right? Then you will, for the same prompt, you will actually see multiple different responses, right? And then what you can do is you can actually consolidate through the another one. So this way you can ensure that the responses are different for the same prompt, and you can use that. Similarly, you can also use the other one is also called frequency penalty and presence penalty. Frequency is if it generates a text, because the way the texts are generated is what? If you look at the response of the models, it generates the first word, then the second word, then the third word. It actually generates those tokens or words in a sequence. So when you generate the third word, let's say, and this word is same as this one, right? Then you can apply penalty saying that if the word is already generated, you generate some other word, don't generate the same word. Okay. So probably use a different synonym or different example and all that. Same thing for the presence penalty also. If it's already present in the past generation, there's a penalty for that. So this actually also helps you to generate responses which contains variation of words, or the expressions also vary a lot, right? Now imagine you are actually generating a report about cricket. The cricket itself is a word that repeat multiple times. So you can actually apply a penalty to that so that it looks for some other responses. So too many cricket words in the report itself doesn't look very nice. So you probably can, but mostly you use this for a more of a creative writing to ensure that new words, new concepts, new tokens are introduced in the responses. So there are very nice controls are there for almost all generative AI models support this kind of controls for the models. So this becomes very important parameter, especially when you're doing a self-consistency prompting technique, right? You can use all these parameters to control the response generation, right? Okay. There are also very interesting papers are there. For example, this one is published by DeepMind, which is a Google company and very popular now. They're one of the lead researchers in the field of AI. They did a research on chain of thought only. And but the chain of thought itself was very different. So in the instruction, when they ask a question, they ask also, let's think step by step and solve it. This is typically what people mostly use. When they ask and response, think step by step and then give the response, right? And interestingly, of course, this could have been come from the training data itself. So you ask the same thing. Let's work this out step by step. Semantically, both are same, but one has a better accuracy compared to the other. In fact, very interestingly, when you write, take a deep breath and work on this problem step by step, has the best response from the models, right? Of course, these are not very deterministic. I mean, these things keep changing in the model just to show that how the models are tuned to a certain way of asking the question, right? because these models are not humans, okay? And all that they have learned is from the training data. And if the training data has a certain way of asking questions in certain manner, so they get aligned to that. If you ask in a very similar fashion, typically the models have a better response. Okay. Of course, this is something that you still have to learn, probably experiment and hit and try. But this is just to show that there is a variation even within chain of thought, the way you ask the question, the way you ask the, accomplish those steps also. Okay. And then there's another paper published by Microsoft and other colleges. It's a collaboration between multiple different universities. And if you look at very interesting, he's saying that giving a small math problem, saying Roger has 5 tennis balls. He buys 2 more cans of tennis ball. Each can has 3 tennis balls. How many tennis balls does he have? Right? Let's think step by step. So this is one pass. But sometimes what you do that is you ask the question and you say that read the question again and you repeat the question. Typically, this has a better response. So this is called rereading the question. You specify the question again. Typically, the model has better responses. Again, this is benchmarked again mostly math problems. Whether it will work for your specific context or not, you still have to kind of experiment and find out. There is no way, but just to kind of telling you that prompt engineering is a lot of trial error still, okay? And a lot of these concepts come, which are very subtle, but you still have to try it on your specific context and do that. But more established prompting techniques are these, right? That we saw. And you must always experiment through these patterns to ensure that you get a better result. Which one you still have to kind of do a benchmark, compare, do a trial error, and then have an evaluation strategy to ensure that to find out which one works best for you. Okay, I think there are some questions.
We have a new question, which is, can you explain top P sampling?
Okay, top P sampling is like, let me show. I'll show from this example only. Let's say you ask, I ate the pizza while it was still. So the model, here is the model, the LLM model, which predicts what is the likelihood of the next word. And then so okay, it predicts the probability for is hot is going to the next word, or warm is going to the next word, or cooling is going to the next word. It basically predicts the probability, isn't it? Now, the default understanding is whichever has the best or the highest probability is chosen as the next word. In this case, assumption is what? I ate the pizza while still hot. But not necessarily. Okay, because this will be very deterministic and repetitive, monotonous, right? What LLMs have adopted is saying that we will not always pick the best word. We'll pick one among the best word. One among the best word. Right? So best words. So what are the best words? So let's say in this case, what you do is we define something called top P sampling. I'm just giving an example here, right? I'll say top P sampling is 0.9. That means you look at the probability of all the top words and cumulatively where you reach 0.9. Let's say this is 0.8, this is 0.5, this is 0.3 and 0.2. No, 0.0, 0.0302. That means cumulatively these 4 words has 0.9 probability, isn't it? Then this becomes the set of best words that can be the next word. And then it chooses randomly one of those words. Again, it do a sampling without replacement from these words. Of course, when you do a sampling, of course, this word has the highest probability of being chosen, but the other words also have some probability of being chosen, right? So top is sampling. So when you say top 1, I'm just giving an example, right? So that means you always choose the best one. It's also called top K, by the way. But top P sampling is the cumulative probability of the words which can be the best word, which can be one of the words that can complete this sentence, and then choose from that, right? The top P sampling, if you choose a very small number, let's say 0.2 or 0.4 or 0.1, then always the first word will be chosen. But as you increase, there's a possibility that some other words might also be chosen, right? That's why if you ask the same question to the model, every time there will be some variations would be there, right? Unless, and if you want extremely reproducible, every time I ask the question, exact same response would come, then what you can do is you can reduce the temperature to 0 and top P sampling to a very small number. So this will ensure every time you ask a question, the response will be exactly same. But as you increase the temperature and increase the top P sampling, there's also a possibility that the token that gets generated can vary. Okay, so this gives LLMs some kind of persona, saying that every time you ask a question, I answer in a very different manner, without, of course, compromising on the quality or the factuality or coherence of the sentence itself. Got it? Makes sense? Yeah. So what we do is we'll take a small break and then come back at 9:45. Is that fine? So welcome back. There are also every provider, right, provides certain guidelines they have found, right, to be appropriate, to be adopted while creating prompts, right? For example, I given the link here, the OpenAI itself or Anthropic itself would have provided certain guidelines. I'm not sure. Yeah, prompt engineering best practices. So if you see here, in the OpenAI documentation itself, the prompt engineering, right? So there are 6 strategies they have given for getting better results. Similarly, if you go to Anthropic, let's say if you're using Anthropic Claude models, so Claude models have their set of prompt engineering best practices, right? So you should follow them, but these best practices are not very different. If you read through them, they're kind of converging into same set of principles and kind of aligns with the patterns that we have discussed already. So let's go through quickly because it makes sense. Also, as a manager, you should ensure that your team or architect, whoever is building solution around a particular provider need to go through this best practices and adopt them, because they are kind of proven over a period of time, and the lessons that are learned from their customers whom they're interacting with and understanding what works and what does not, right? So 6 strategies for getting better results include, the first one is write clear instructions. So your instructions is to be extremely clear, right? For example, ask the model to adopt a persona. Okay, so this is very similar to kind of you always define a role. Okay, so whenever the model is responding, if it adopts a persona, it knows better how to respond. Use delimiters to clearly indicate distinct parts in the input. For example, when we wrote, right, we have a clear indicators. This is an instruction. This is the context. This is a question. These are examples, right? So you provide an indicator. Okay, so these indicators could be anything, especially Claude models. They normally love XML tags. So example, and at the end of examples, you can say example. All right. So this could differ how these indicators, I think, use XML tags. So they love XML tags. So if you're using a Claude model, the indicator, if you use XML tags, it works typically better and gives a better response. So these are very nuances, subtle differences that you should be aware of while implementing solutions. And provide examples, right? Those are important. Provide reference text. That's basically giving the context. Okay. Always provide a reference text. This is a context. And there is something called RAG, which of course we'll come and discuss in the next session, which is an important framework for building solutions to kind of incorporate your private and external knowledge into the solution. Split complex tasks into simpler subtasks. This is like a chain of thought, right? So when you ask him to, provide a response, you can actually create detailed subtasks, right? And give the model time to think. This is same thing as your chain of thought. Rather than giving responses directly, you can also give chain of thought. So almost everything can be aligned with the other responses. Use external tool. This is something that we will explore a little later. Test changes systematically. Okay, this is a very important like ablation study people do, right? So whenever you create a prompt and your response is not desirable or is not giving the accuracy, you make a change to the prompt. But you do not make a significant change to the prompt, because then you will not be able to understand what change has significant impact on the outcome, right? So that's very important that you do an incremental yet a measurable change so that you know what impact it has. So let's say you adding another subtask. So let's say you decompose a complex task into 4 subtasks. Now you found that probably it's missing out a step. So you change that to 5 subtasks, but don't change it to like 10 subtasks immediately. Then you don't know, the outcome of that, the impact of that. So you always make changes and test changes systematically. That's very important. So these are very interesting. Write clear instructions, provide context, split complex tasks, simpler tasks, give model time to think, tools and all those things. These are best practices that can be adopted. Okay. If you go through one provider's best practice, the other provider also has a very similar, could be a little bit of variations in that. For example, in Anthropic Claude, I'll come to prompt generator. Be clear and direct, same as clear instructions. Use examples, multi-shot. This is also called few shot examples. Chain of thought, right? Chain of thought, few shot and chain of thought. Use XML tags. This is like a delimiter. Give Claude a role. This is we always in role, right? Pre-fill Claude's response. This is something very interesting and specific to Claude only. Chain complex prompts. That means this is decomposing, right? Decomposition of complex tasks. Long context tips, we'll look at that a little later. Pre-fill Claude's responses. Whenever you're asking a question, right, if you can pre-fill it, right, then the Claude typically gives a better response. For example, if you're expecting a response in a JSON object, the prompt should end with a curly bracket. Then it gives a better response. This is actually very peculiar to Claude, but not peculiar to GPT-4. We don't have to give that. It automatically understands, starts with a curly bracket. This is kind of enforcing the model to give a response in that. But remember, when you get a response, you again have to prefix with a curly bracket for it to be a valid JSON object. Right? So this is something that is very peculiar, but then this is how the models are built. Any questions? Okay. So are there any emerging patterns for specific tasks? So let's look at some of the emerging patterns for specific tasks. For example, structured information extraction, right? When I want to extract structured information, most of the models are nowadays have integrated with something called Pydantic. Okay, this is a little more technical specific. This is same as a JSON. You can provide a JSON schema like the one that we have provided a JSON schema. Second. Like we have given a JSON schema here, if you know, when you ask for a response from the model. But the same thing can also be given, especially when you do an API integration with the models. You can also give something like a Pydantic class. And this is an API where you're asking a model to respond. So OpenAI has a chart completion. This is called chart completion API, right? So you ask a question, response. So that's the API is called chart completion API. Nowadays, most of the models are following OpenAI standards. So if you understand one API, I think it becomes easier for others. But of course, you don't have to really go through detail. I just give you an example. So simply saying that, here's a question that I want to ask, is an instruction. This is the model I want to use because OpenAI has many different models. You have to specifically say which model you want to use. And then response format. How do you want to respond? You can actually give a class definition here. Okay. So this is the class definition, saying that when you respond in a format of a class object, which will of course internally JSON representation. You should have a name field, date field, and participant field. This is important because sometimes there is, of course, this LLM models, right? As a human, of course, we interact and get response. Sometimes these LLM models are integrated with our downstream applications, right? And downstream applications, typically, when it gets a response from the LLM, if it's a more structured response, then integration becomes easier. And so we can actually use something like Pydantic. So Pydantic is Python's way of enforcing, schema. There's also another called typing, which Google uses. Also, there are many different ways of doing it, but Pydantic is quite popular in this case. And the beautiful feature of Pydantic is you can also introduce constraints. Let's say you want the model to respond in this particular fashion, where you should have a, let's say it goes to a news article. You sent a news article to the LLM, right? You sent a complete news article. scraped from the web and sent to the LLM and asked it to extract certain information from it. This is primarily for structured information extraction. And so, okay, you extract the title, the date, the location, and some summary and some tags, entities, right? But then you can also ensure that these fields comply with certain constraints. Okay. So you are describing what it is, but it's saying that it should not be more than 150 characters. The date should be, of course, this particular format. The location should not be bigger than this, right? You can actually provide all these constraints also. And nowadays, models are actually kind of trained to comply with these constraints. In fact, recently OpenAI has come up with an API with a parameter called strict. And when you say true, it will ensure that it follows that constraints very strictly. Of course, you cannot enforce very strictly quite a few models. They try to follow the constraints given. If the constraints is not fulfilled, they might little bit of, violate those constraints or probably hallucinate sometime. But there's also a mechanism to enforce strictly also. So for a structured information, for example, I'll talk about 2, 3. One is structured information extraction. Right. This is an important use case for organizations. So in the case study that we discussed earlier for the incident.io, which goes through the previous messages by the collaborators about an incident, they use structured information to summarize. So they extract specific information and provide the summary in a very structured way. So structured information extraction is very important use case of generative AI. Second one is summarization. How do we actually summarize an article or anything that you want to create a summary report or something like that? Let's say you want to read a report and you just don't want to read the report completely, you just create a summary. One is typically what you do. We say, model, can you summarize this? LLM models typically has a problem called lost in the middle problem. Lost in the middle. So if you give a very long report, the models typically focus mostly on the beginning and end of the report, and middle of the report typically gets very less attention. To avoid that, what you can do is that 2 different patterns are there. People use it to summarize. So you take the whole article or what the context, rather than providing the complete context for summary, you split that into chunks. Okay, so these chunks can be, very brute force chunks. For example, you can say every 1,000 characters you chunk it, or these chunks can also be semantic chunking, or can be, section wise, which I can take first section as first chunk, second chunk, and so on and so forth. Again, there are different chunking strategies are there. Some chunking strategy we'll talk about when we come to RAG. So you chunk them, and then what you do is each chunk you summarize independently. So this is also called a map reduce pattern in summary. So this chunk is summarized, this chunk is summarized, and this chunk is summarized. And then what you do is, so this is an LLM interaction here, LLM interaction here, LLM interaction here. So that every chunk gets equal attention, and you extract information from every chunk, every section, or every whatever, the way you chunk it. And then you take all the summaries and send to a more capable model to create the final summary from these summaries. So this is like a map process. This is like a reduce process. So this summarization typically is a better summary response compared to simply send the article to a LLM model and ask you to summarize. Right? So this becomes a challenge sometimes when the report is quite long. So this is one of the most widely used approach to summarize longer reports. The other one is you can also do something called refinement pattern, where you still can create a chunk. Okay, so the summary gets evolved over a period of time. So you send the chunk one first, create a summary. Then what you do is, this is the first LLM interaction, same LLM only. Then you send the second chunk along with the first chunk summary. That's the context, saying that this was the summary from the previous section, and this is a new chunk. Now, can you add this chunk's information to the previous summary and create a new summary? And then when that gets created, you send the third chunk with the summary and create the final. So you refine the summary over a period of time. And when you get the final summary, you can see the summaries, quality of the summary is much better compared to what you would have done by simply sending the report and say, create a summary of the report. So these are different approaches or patterns that has emerged over a period of time to kind of, address the limitation of certain models. Of course, over a period of time, some of the models have become much more capable. Like they can take much longer context, much longer text as an input. But you can increase the chunk size in that case, rather than sending the whole report or chunking them into very small pieces and create summary. You can increase the chunk, still do it in a phased manner. So that gives a much better summary or response in comparison to summarizing the whole report at once. I'll just wait for a minute if there are any questions. No questions, right?
One question from Yeshwan. Do models refine today by themselves, or do we build refining in solution?
No, in the solutions you have to build. You can't, the models won't do refine by themselves. So you have to manage those interactions with the models yourself. So that's where agents come into picture. We'll talk about agents. So you take the context of the report, you chunk it and send to the LLM. So this is your solution, and get a summary response from you combine with a chunk and send it, again combine and send. So you have to manage this in the solution. The model themselves cannot do. Right. This is something that you have to do it yourself. Okay, so next one is a very interesting question. Does the model remember my past interactions? So whenever you go to ChatGPT and you ask a question, right, in a particular thread, right, you have to create a new thread. Let's say I ask the thread. So it basically, when I ask a question, it remembers, right? But it's not the model which remembers, it's the ChatGPT system which is built on top of the model that remembers, right? Your models, your LLM models, they're like GPT-4, right? Or whatever, your Claude model, they are completely contextless. They don't remember anything. So the way the model works is, you send a request or prompt, the model generates a response like a tokens, the response is returned to you, and the model is completely gone. The state is completely reinitialized, whatever. Again, next prompt comes in, again it gets a response back. So then how do you actually simulate the conversations where it has to respond to the prompt that I'm sending now, along with the historical interactions also? That's what ChatGPT has done. But ChatGPT is not a model. ChatGPT is basically a system built in front of the model, which interacts with the model later. If you see here, in ChatGPT also, I can select the models, isn't it? When I go, I can select which model I want to interact with. So these models are typically what? They are contextless. But the application itself is context because they keep track of our histories. So what they do is, so there is a two kind of concept. One is called single turn and multi-turn conversations. In single turn conversations, no context is retained between interactions. Multi-turn conversation, the context has to be retained across multiple turns. Again, if you're asking to create summary, answering specific questions, independent questions, right? Structured information extraction, they're typically single turn conversations. But chatbots, right? They're multi-turn conversations. You have to remember your AI assistant or chatbots, there has to be, you have to remember the previous conversations. The single turn is simple one-step interaction, which handles tasks requiring follow-up questions and all that. Now, how do they do it actually? Is then there's a concept of messages. So whatever messages that we send, right? So whatever messages that we send to the LLM, these messages, basically when I say messages, the prompts, right? Messages or the sections in the prompts. There are three kinds of messages. One is called system message, one is called user message, and one is called assistant message. This is especially when you're doing a conversational system, chatbots. For example, you are a helpful assistant skilled in explaining programming concepts in simple terms. This is your system message. This is your instruction. This is your instruction in the prompt. Then you are asking a question saying, what is the difference between supervised and unsupervised? This is a user question. Okay. Typically, the system message and user message are combined, and you create a prompt, right? And you send it, right, to the LLM. For example, in our zero shot also, you can think like the role, the instruction, the context, right? Everything is like a system message. This is like a system message instruction, which remains constant every time you send a request. But the question saying that, can you now classify this particular review? Right? This keeps changing, isn't it? Every time you're sending a different review to be classified. So this part, the top of this part, typically is a system message. And this is more of a user message, which basically keeps changing. But this is again one turn interaction. But in the assistant, is a multi-turn interactions. So this is system message. This is user message. And what the LLM responds with it. So when you ask this question, it says supervised learning involves label data, whatever, that's a response. That is basically called your assistant message. In fact, in the chatbot also, whatever you're asking here, for example, let's go here. So this is your user message. This is your assistant, the response that is gone from the model, right? You can also add, by the way, you can also add system instructions here. Like if you go to if you let's say you are exploring about a particular concept, right? What you can do is you can go here and customize ChatGPT, right? And you can actually provide some custom instructions. Typically, what people do is they provide the role or better understanding of who is asking the question, where you are based, what do you do for work, what are your hobbies, subjects. It's an example, okay? It doesn't have to be exactly like this. You can provide this, and you can also provide something called how the ChatGPT you want to respond in a particular format, in a particular tone or style, right? You can actually configure that. So whenever you are asking a question, what happens is whatever you have given here as instructions, custom instructions, that gets pre-pended to that. So it actually gets added to that. Then the response goes. So every time you ask a question, right? Let's say you're asking a question as a manager, right? Then you can actually, in the custom instructions, you can provide what is that product that you're managing, or what is the project that you're managing. Okay? Give some context to it so that your response becomes highly customized to that. So that is basically system instruction. And what you're giving is a user, and this is your assistant message. That's how it is classified. Understood? So three kind of a system message, which provides context, guideline, instructions, contains the prompt and query by the user that you're asking every time, and this is the response from the LLM. Then what happens is, when you do a multi-turn interactions, right? When you do a multi-turn interactions, let me quickly explain here, becomes it easier to understand. So let's say you're saying that you're a helpful assistant. So your system message, then user, you asked a question, right? So this is your first question, user message U1, and the LLM sends a response. This is called assistant message, right? This is A1. This is S. This not, they will never change it. This is basically the broad guideline about the interactions. Then when you ask the next, based on the response, let's say you ask another question, the user asks, right, a subsequent, a follow-up question. Like for example, let's say you are doing a chatbot interactions about a product refund, or you're doing about, you know, a banking products interactions. Then here what happens is there's a LLM here. There's a LLM here. Clearly understand this because this is important, especially if you're building chatbots. So when the user asks the question, the system message along with the U1 goes to the LLM as a prompt, right? And you get a response called what? A1. Now, when you ask a follow-up question, what happens is, because it also need to understand the context of the previous interactions, your S, the system message, plus U1 plus A1, right, plus U2, this is all sent to the LLM in a prompt. So it gets appended. So when you see in the next follow-up question, it sends all these previous interactions along with it, so that the LLM understands what the previous interactions are. Because LLMs are completely context-free, contextless. They don't remember anything. Because thousands and thousands of people are interacting with the LLMs, right? Those cannot contain interactions. So this particular system that you see is actually implemented by ChatGPT by default, which interacts with the model. So if you have to use the model, you have to build the system yourself. And then let's say it sends a message A2. Now user asks a third question, U3. Now what happens is it sends the system instructions, U1 plus A1 plus U2 plus A2 plus U3. It sends to the LLM. Okay, and then gets your A3 response, and so on and so forth. And your LLMs are actually fine-tuned on similar kind of data. This is called conversational fine-tuned. Most of the models are actually tuned based on that. This is how we retain the memory or the conversational memory. Okay. And if you see here, there's an example here. Yeah. So when you ask initial conversation history with 3 past interactions, this is how you send the messages to the model. You're saying, okay, this is a system instruction. You're a helpful customer assistant. This is the first question. I need help with my order. Sure, I can help. That's the first interaction. Second interaction. Now I'm seeing the third question here. So I have to send the system message, the first interaction, the second interaction, and send it. Then it understands the complete past history and then responds. That means it takes into account the context of the third question. So this is something that you have to build into the system. This is not by default, by the way. Okay. So there are actually products, frameworks are coming to take care of this. Okay. But you have to take care of the models don't remember anything by the way. So with conversational memory, without conversational memory. So this concept here. Okay. So this is called your conversational memory. Okay. You can retain that in cache or in database also. If it's the history has to be, so next time when the user comes and asks question whether you want the previous conversation or not, that's a product question that you have to answer and do it. Understood? Now, one thing you would have also realized that there are multiple different strategies to build this memory. Because if you remember everything, each conversation as it is, right? Then every time you send to the LLM, you can see every time you send to the LLM, right? You have to remember all your U1 to UK, A1 to AK, right? All past K interactions along with UK plus 1, the new query. All this has to be sent to the LLM. So this increases the cost. So that's why assistant AI is complex. So increases the cost with the context window increases. Every time a new question asked, the context window increases. It becomes much more complex. So every time you ask a ChatGPT, right, a new question, all your previous interactions are sent along with it. That's why if you're asking a new question, which does not require your past interactions, you should always go and create a new thread. Otherwise, what will happen is your cost will increase. Of course, the ChatGPT is a fixed subscription. It doesn't matter. But when you're doing it on a application, API based, every token counts. Every token adds cost to the interaction. Now, how to deal with this then? So there are multiple ways to deal with this. One is called window memory. One is called window memory. Okay. And the other one is called summary memory. So what you do is when the user interacts, U1, A1, U2, A2, U3, A3, U4, right? In the window memory, what you say is you set something called how many past interactions you should keep track of. Let's say you said 2, right? So when you ask a second question, this is sent along with the second. When you ask the third, these 2 are sent. But when you ask the fourth, only the last 2 interactions are sent. So much older interactions are, right, are dropped. They're basically discarded. So just to control the cost of interactions. So you can actually do a sliding window. You only keep last 5 or last 10 interactions. Rest all can be discarded. But this can actually lead to loss of information, right? They can lead to loss of information. That's why what you do is something called summary memory. So what you do is once in a while, let's say once you complete 5 interactions, right? You send to the LLM all the interactions and ask LLM to kind of summarize, saying that in those interactions, what was the most important information exchanged? Let's say in 100 words or in a JSON object, right? You keep track of that. And then you discard all of it. Either you store database, but don't send to LLM anymore. You simply create a summary and keep it. And next time when asked, you simply summary, you say that this is the summary of the past interactions, summary of information exchanged in the past interaction, and this is a new query. Now respond with that. And this is how you actually manage memory when interacting with the models. Got it? You see, these are not simple solutions. You have to understand these concepts, especially when you're dealing with creating complex solutions. You are also under limitations and create this kind of solutions to ensure that. So conversation buffer window, K6, conversation summary memory, right? So these are actually, this is of course all the conversations you might hit a token limit. Of course, the limit is increased now. Models token limits are typically very high nowadays, context window, but still it comes with a cost. Any questions on this one? So you looked at 3 different ones: structured information, summary patterns, and conversation. Right? There are different patterns that we follow. I'm just waiting for any questions.
There's one question from Yashwant. Is the summary pattern also something we should take care to build in the solution always?
Yes.
Or is it available out of the box?
So it's available out of the box if you use a framework like a long chain or whatever, which is all, of course, like building a solution. But LLM does not do it. The language models don't do it. You still have to build outside of it. Either you can build from scratch or you can use something like a framework to do it. Okay. We'll talk about frameworks in the next session, which are the most commonly widely used frameworks to kind of accommodate tasks. Sorry. Okay. There's one more feature I'll discuss before you move on to a case study. One more case study. There's something called function calling or tool use. So these are different capabilities that you can add to the model. Now let's look at a very simple example. Let's say you want to understand how the value at risk is computed for a stock. Typically, what people do, investors, right? When you do a risk analysis, they ask the question how to actually calculate the value at risk for a stock. So if you ask this question, of course, GPT or any of the models know exactly the steps required to calculate the risk. So they basically say, okay, here's the step-by-step approach to calculate the VAR for a single stock. Okay, you don't have to understand if you don't know, but that's fine. But then if you ask question saying that between stock A and B, specifically, given A and B, but it can be actual name, which stock has a higher value at risk? Okay, I asked how to calculate the risk here, but now I'm asking a question which is a higher risk given their daily returns in the past 6 months. Now, the other limitation of model is what? They don't have access to the external data, right? Now, if you ask this question to model, that's okay. I know how to calculate. If you provide that information, I can probably calculate, but I cannot access the information for you directly and calculate for you. Okay. So this is external knowledge that typically the models do not have access to. But then how do you build a solution which can also access external knowledge or information? Like if you ask a question, it can browse, it can access, call API, right? And then take that information and finally create a response to you. Okay. So nowadays, of course, they have added a feature. If you see in ChatGPT, search the web. If you click on this, right, and ask a question, it go and search the web, and then create a response for you. Otherwise, if you don't search, it will basically either you provide the information explicitly here, or it cannot do that. Okay, so to enable this is of course searching a web is just one particular function that is enabling it. But let's say I want to access the live feed of stock market, right? Then of course I can't do it here. So it provides a feature now, okay, which is basically called your function calling. Function calling. So connect models to the external data and systems. You can define a function, and the function will access the external data, and you can use that function to retrieve information and send that information to the LLM. So now if you say between stock A and B, which stock has a lower value risk at daily returns, you have an application where you can have a function which actually can access the data. You can send that function definition, right? Definition to the LLM. If you have only one function that has to be called every time, it's fine. But let's say you have a function 1 to function n. There are many different functions out there. Now, based on the question asked to the application, one of the function has to be invoked to retrieve information, right? Then you can send the definition of the functions to the LLM. The LLM understands your question, your prompt, and also decides which of the function will actually help you. Let's say F4 will help you to actually answer the response, to generate the response. Then it sends a response back to the application saying that, can you invoke the function F4 with these parameters? The parameters are defined by the LLM. Then you come back and invoke the function, right? Because you don't know which function to be invoked, right? So that is in part of the conversation. You invoke the function and then sends a response to the LLM saying that this was the response. Now can you answer the original question? So now, because LLM has the original prompt, which is of course sent as a part of the memory, and the function output, now it consolidates and responds back. Following? So this is something called function calling, enabling function calling for the generative AI. So this way, you can integrate many different systems, your internal systems. Let's say there's a refund application there, right? Just give a simple example. Another example. where the user saying that I have bought this product, can I refund it? Right. Now, what is the application? Right, LLM, and saying that, okay, LLM is okay, this is a refunds request. For the refunds request, I need to know whether the 30-day warranty has elapsed or not. Okay, and you have defined certain functions which can check all those from the database, right? So your LLM will say, can you invoke this particular function to check 30-day lapse period? So you come back and basically call that and say, saying that, okay, yes, the 30-day expiry period has elapsed. Then what you do is you send the response back to the application saying that no, it cannot be refunded. Or if has not lapsed, then basically some more. Can you retrieve more information from the other function and so on, so right? So this way, you are integrating your LLM with your external systems. Okay, external means external to the LLM, could be internal to your organization through your application using something called what? Function calling or using tools. So this actually, kind of expands the capability of generative AI solutions. Now you can integrate systems into LLMs through function calling, right? You can expose this, services in your organization that can be integrated with your, let's say, conversational AI or chatbot, and you can expose them as a function and integrate through your LLMs so that people can interact with it through a simple natural language conversations. So this becomes an extremely important, pattern. Same thing also you can do, right? For example, you can have a tool to access external data and also internal databases, multiple different tools. An LLM deciding which tool to call when based on conversation and flow. Okay, so that basically becomes an important part of it. It's also part of the agents. We'll look at an example of this later. So you send a prompt along with the function declarations, which are the function, what the capabilities, right? And the model, the LLM basically says which function and parameter value has to be invoked. You invoke that and send that response, and that finally the model response, the prompt response, this goes to the user. Okay, so all these interactions can be managed through the function calling. So overall, if you see, there are many different possible ways to use your LLM or a generative AI model to build different kind of solutions. Structured information extraction, summarization, conversation, and your tool or function calling to integrate external systems. These are the important ones. And if you look at your, models also, typically they will have a how to function call, how to structured output, right? And of course, we'll look at fine-tuning distillation later. There's some of the important aspects of the models. I'll take a couple of minutes to explain one more. Anthropic actually has a very interesting feature called prompt generator. And GPT also has something called prompt canvas. I'm not sure whether you guys have seen this. They're very interesting features. So now Anthropic provides a feature to generate a prompt itself. Sometimes writing these prompts are extremely complex tasks. So it can actually help you to kind of elaborately write a prompt. So Anthropic actually has a feature where you can say, generate a prompt for me. So it gives some basic detail about the task. For example, here is something that I asked to do it. To write a product requirement document, would typically be called a PRD in product management. for developing a system to review and respond to customer reviews of a restaurant. It's to take care of detailed analysis like reviews, personalized response, and take care of all system requirements. Okay. Of course, I can simply give this to create a product requirement document, but this is still not a very comprehensive way of asking, like a chain of thought, right? So what I do is if I input this to generate a prompt to Anthropic, right? It will actually, sorry, I've already done this, so I'm just going to show it to you. You can try it on if you want. So I gave this to Anthropic and see, it actually has created a prompt for me. Very detailed prompt because it understands the concept of product requirement document. So it created a prompt saying that you are tasked with writing a PRD for developing a system to review and all that. Okay. And it also gives you a placeholder to write the restaurant name and give an example of the review to better understand it. So I have filled it, of course, later. And also say that the requirement document should have this following sections. If this is something, if you can give a detailed one, the response would be much better. But I didn't know or didn't have time to write this. So I asked them to generate. So it basically says automatically generates sections: introduction, review analysis, personalized response generation, and so on and so forth. Now what I can do is now I can take this prompt, right? I can take this prompt and use it, right, in something called GPT-4 with Canvas. So this is a feature that's available if you can use it. This is available on a paid feature. And yeah. So if I go and I give that, so here I've given it here, the complete, prompt here. So I use Anthropic to generate a prompt. And the prompt I came and gave it to the ChatGPT here, which of course I could have done it here itself. And then ask it to generate a PID document. Now you can see the PID document is much more comprehensive because the prompt was so comprehensive, the response is also quite comprehensive here. All right. So this is the something that you can, as a feature, you can actually leverage to write a prompt and get a better response. And then this is called Canvas. In Canvas, what you can do is now you can review this and say, maybe you can little expand on this more. You can select that and you can also, expand on this point, on this topic, right? You can ask. So what you'll do is you'll go and review a little more, expand on that. So you can actually live editing also you can do on the prompt responses. So these are very interesting features. Prompt generation and Canvas can actually help you to, kind of leverage this models in a much better way. Okay. Typically, when I interact with these models, especially ChatGPT and Anthropic, I take help of writing the prompt, especially for complex tasks. Then I make some editing, required editing, and then come back and create a response here. The response also I can do a live editing, which goes back to the, right? This is called Canvas for editing live on the responses. Something that you should be aware. So probably you're already aware and using it. Okay. I'm going to go through the rest of the topic later, but I just want to kind of end this session with one more case study. So this is a case study from GoDaddy. Again, when they created their generative AI assisted chatbot, right? So the 10 important lessons that they learned in operationalizing the models. So let's go through that quickly. Before that, are there any questions? I have some hands-on exercise also there. What I'll do is I will do a mid-week session, about 1 hour session. people who are interested in running the code for some of these ideas can join. I'll send the link and we can do that later. Okay, but everybody may not be interested in writing code and technical solutions, so I just kept it a separate section. So let's go through. Any questions so far? Okay, so let's look at LLM from trenches. 10 lessons learned operationalizing models at GoDaddy. The first lesson they learned, this is some printing error, so I have basically kept it as a. I'm going to inform that one prompt is not enough. So what they realize that when they build a solution, so let's quickly go through. GoDaddy receives over 60,000 customer contacts every day in our messaging channel, right? So the possibility of LLM technology applied to customer support, which is of course one of the most important use case people use nowadays. Early experimentation demonstrates that LLMs outperform older NLP units. Okay, so the rule-based and intent classification kind of chatbots. But operationalizing LLMs isn't effortless. Okay. And we have learned a lot of lessons operationalizing these models, and this was discussed the finding. This is a very wonderful article blog. I like a lot because they clearly specify a lot of things. So they built something called AI assistant. The assistant communicates with the customer until it could classify the conversation into one of the 20 support topics. When the customer asks a question, one of the first task of the AI assistant is to kind of classify into what actually they're asking about which particular category, because all requests were different categories. So it's categorical classification. Right. So when the topic was identified, the assistant could ask set of questions specific to that topic. Because only when the customer asks something, which let's say, can you renew my domain? GoDaddy, right? Or something about renewal. So the AI assistant's first job is the question is about renewal or like, payment failure or any other service. The first thing is to classify into one of these categories so that once they know it's a renewal, they can ask specific question about renewal only. They should not ask any other question. But if you so once the feedback is collected, assistant would use information to route the conversation to a support queue matching the topic. Though our initial experiment performed fairly well, we started to see problems with our implementation as we added more and more topics and questions. So initially what they did is, when they designed the system, it was probably a single prompt, right? Saying that if this is the topic 1, this is the set of questions. The topic 2, this set of questions. Topic 3, this set of questions, right? So based on that, the AI assistant would ask questions based on the topic. But as the number of topics started increasing, topic N, it becomes quite complex. So LLM would sometimes ask questions unrelated to the target topic. Okay, so in this case, what happens is it becomes a challenge. So instead of asking questions and routing to a support queue, the assistant would walk the user through a process of fixing the problem, sometimes completely unrelated. And the new prompt bloated to 1,500 tokens because it contained all topics and questions. Okay. And the accuracy of our prompt declined as we incorporated new instructions and context. So what they did is, they decomposed that and transitioned to task-oriented prompts could achieve greater efficiency in complicated conversational flow and focus on a single task. So they decompose that into several prompts. The first prompt is only to classify it's a topic 1, topic 2, topic 3, topic 4, whatever. If it's topic 1, there'll be separate prompts, right? Only for topic 1. So now this will drive the whole conversation because they've already identified. Similarly, there'll be different prompts for different topics. So which initially they had only one single prompt that decomposed into multiple different prompts. So we used task-oriented prompts at key transition of a chart flow. This is also called handoff. A user needed to transfer to a human agent or execute task to vital information. So multi-prompt architecture using a controller delegate pattern. Controller is the initial prompt, which is understands which particular topic it is, and then delegate it to the right prompt. Okay, so there's a mega prompt which serves the controller and passes the conversion to the task-oriented prompt. So this is a very good design. In fact, there's a paper there which is actually published by Salesforce. You can read that if you want. This is a very interesting paper, and there's a link here. Okay, how they have a controller and specific task prompt and all that. This is a very interesting pattern they follow it. But the whole idea here is, if you look at the whole idea here is, do not try to accomplish through one single prompt. Okay, you decompose that into multiple, several task specific or task oriented prompts. That's one lesson they learned. Be careful with structured outputs. Plain text responses from AI bots are ideally suited for chart scenario, but maybe less productive in system built around AI analysis. So structured responses as a JSON or code should be requested as needed. So very important that your output should be very structured. Okay. Minimize the prompt temperature for structured results. You see that for a kind of reducing randomness. That's basically more of a deterministic output. They're basically saying that, minimize the prompt temperature. So especially when you're using a structured response output, you typically want a very deterministic output. So keep the temperature less. This is a very important. Prompts are not portable across models. So a common misconception that a single set of essentially text instructions can be universally applied across different models. So if you're changing your model tomorrow, this is also true because most of the models are not backward compatible. Okay, this is something that you will encounter when you're building solutions. That means if you're using a model today and tomorrow you're using another model, even an advanced model, so it's possible that the same prompt won't work. You might have to recreate a little bit of tune it. Our findings shows that not only in this is untrue, even different versions of the same model, like GPT-3, GPT and all that, can display noticeable difference in performance. Okay, so it's important that we tune prompts for each model. There might not be necessary you have to tune completely, but a little bit of, so there has to be a validation strategy, right? A validation strategy to ensure that when you change a model, you validate against it to ensure that it works better. Okay, so teams must continuously fine-tune and test prompts to validate their performance as intended. AI guardrails are essential. We'll go through guardrails a little later, and because we are addressing guardrails as an independent topic later, but just to ensure that you are not answering any questions which are not within the scope of the solving your problem. Sometimes people in chatbot ask very different kinds of questions, right? And ensure that you have the guardrails so that for example, check if there are PIA information or offensive contents are not there in the prompts and responses, okay, which does not lead to a legal problem later. Models can be slow and unreliable because 1% of our chart completion fails at the model provider. Sometimes these models respond very slowly, takes about 3 to 5 seconds to respond. Okay. So you should implement retry logic. Nowadays, of course, the APIs provide retry logic. You can actually provide retry. If something fails, you have to retry. Rather than saying customers saying that, okay, we cannot answer your question right now. So chart systems are very sensitive to latency and reliability issues. Something you have to keep track of. Memory management is very hard. Building conversational AI assistance is managing context of the LLM. This is something that we just now we learned, right? For example, LangChain library includes various techniques like buffers, keep last end messages, summarization, and different techniques are there. So that can be used to, create. So conversational AI assistance, if you're building, you have to manage the previous interactions somehow. Okay, so memory management is not easy, it doesn't come out of the box. You have to manage the context of the LLM. It's best to retain entire conversation for short conversations. Also, premature summarizing user and assistant messages can degrade accuracy of the subsequent responses. Don't summarize after every interaction. You summarize after every, let's say, 5 or 10 interactions. That's better. For longer conversations, summarizing the earlier part of the conversation and tracking named entities are better. Yeah. Adaptive model selection is the future. So change models dynamically. Sometimes what you have to do is you might have to change models dynamically when you're building solution. Your application calling one model, then based on specific context, you might have to call another model. So one scenario is when the past interactions are very large, the higher context models for conversation approach memory limits. So let's say you're interacting with a model, a smaller model, whose context window is only 4,000 tokens. And one of the user's interactions have already crossed the limit. So dynamically, you might have to change that interaction to another model. So this is something that you should keep in mind. Might have to do, but it can be done through summary also. But something you might have to do dynamically. It's possible that your application might talk to multiple models simultaneously. Okay, and there is actually a framework called Gateway, which manages it very nicely. Based on the task asked, it can actually also classify which model can answer better. Okay, and ask that question to the model itself. And one of the challenges that you will face when you integrate with multiple model is the API differences. Let's say you're using OpenAI, using Anthropic and Llama. So APIs are very different, but Gateway provides a kind of common API to interact with the models. But it's a little more complex, but something that you keep in mind that you might have to change dynamically the model interactions in between. Right? There are more architecture questions, probably, The rest all will take later because we have not discussed RAG, right? How to actually use RAG effectively, tune your data for RAG and all that in the next session when we discuss RAG and agents in detail. Okay. So what I'm going to do is I'm going to stop here and ask some, see if there are questions are there. Yeah, I think already responded. Yeah, I'm going to share all the articles and everything in the email. Sorry, in the link that you will get the presentations and videos also. Okay. Any questions? But to quickly recap what we discussed today is especially writing prompts is an important capability, but it's not easy. So there are different best practices or patterns that have emerged over a period of time, like a few shot learning, chain of thought, self-consistency, verification strategies are there. So these are very important strategies to design your prompts, especially when you're building the real world solutions, right? You should also keep in mind that there could be subtle differences between model providers. So though you know the strategies at a very high level, you should also look at specific guidelines in the models, provided models documentation to see which works the best for. Most of them will be very common, but there could be subtle differences will be there. There are also certain patterns for certain tasks, like structured information, you can use pedantic and constraints, summary patterns, conversational AI, right? For example, single turn or multi-turn conversations. There are many different patterns out there. And you can also take help of the advanced features like prompt generation, prompt canvas to kind of iteratively evolve and create a better desired response from your prompts. Okay, so this is overall the discussion points today. We've gone through 2 case studies, incident and GoDaddy. So of course make more sense when we have gone through everything, but I will introduce you to the case studies. I'll highlight the key points. You should also go back and read. Any questions that you can always ask. All right, I'll let next time. Okay, so that brings us to the end of the session today. If you have any specific questions, please let me know. Let me pause the recording.